The island of Penang is located on the northwest of Peninsular Malaysia. The island is linked to the mainland by a cable-stayed bridge, which began construction in 1982. Penang Bridge opened to the public on September 14, 1985, and setting the record as the longest bridge in Southeast Asia, measuring 13.4 kilometers long, with a cable-stayed midspan of 225 meters. The midspan caters to a 3-vehicle lane in each direction, with 4 pylons each holding 12 levels of cables. Each level has 2 side span and 1 main span cable, making a total of 148 stay cables. Currently, 135,000 vehicles commute daily on the Penang Bridge, causing major traffic jams at peak hours and during public holidays. To ease the burden of bridge users and accommodate this demand, a large-scale upgrading exercise of the bridge began in 2007, with 2 projects running simultaneously. The first project is to expand the bridge's 2-lane sections to 3 lanes for both directions, and the second to complete 117 cable stay replacements. The Penang Bridge All Stays Replacement Project was awarded to the UEMC Freysinet PSC Freysinet APTO Consortium. The project is unique not only because this is the first time that a full cable stay replacement of this kind has taken place, but also because the bridge has to remain open throughout the upgrading works. As safety is of Freysinet's utmost concern, the area was designed to enable a safe yet workable site while ensuring no risk to the public. Transversal platforms allow workers to cross from one side of the bridge to the other without having to cross the traffic lanes. C platforms gave easy access to the underside of the blisters and harnesses. Rails, tow boards, nets, tools on lines and daily housekeeping ensured that working at height was safe for both the workers and the passing motorists. The Malaysian Highway Authority chose the consortium for the replacement project as Freysinet's cable stay technology has a proven track record in design life, serviceability and speed of installation. The parallel strand system is constructed of individually protected 15.7mm diameter 7-wire galvanized and waxed strands, also known as Freysinet monostrands. The strands have a design life of 120 years, thanks to their high durability and low relaxation qualities. At either end of each stay cable, the strands are held by anchorages, which firmly grip the strands in jaws and create a wax-filled, sealed environment for the strand ends. Between the anchorages, the strands are protected at the deck level by a steel galvanized anti-vandalism tube, to which is screwed a HDPE duct. Each duct is highly UV resistant and has a double helix rim around it, so as to ensure aerodynamic stability of the cable, while maintaining a very low drag coefficient in windy and rainy conditions. For the project, each level of cable stay replacement takes approximately 36 working days. Firstly, a temporary anchorage structure is clamped to the top of each pylon, from which a coring platform is then hung using lifting jacks, giving the platform access to all levels of the pylon. The top anchorage also holds the top of the temporary stays, while a transportable temporary deck anchorage holds the other end. With the temporary stays stressed and taking the load from the existing stay, a lowering system is installed with winches controlling a cable that runs from the top of the temporary stays to the deck. The cable attaches to a series of rollers which hang from the temporary stays and hold the chains that loop under the existing stay. In preparation of cutting the existing stay, a bypass system is installed so that the existing stay may be cut safely without any residual force to it. The outer steel sheath of the existing stay is cut away at the deck level, and the bypass collars are grouted to it. Jacks are then used to stress the bypass until there is zero force to the existing bars. The bars are then cut slowly, one at a time. Once fully cut, the pressure on the jacks is gradually released. Workers then cut through the stay at the pylon, and the stay is slowly lowered onto the deck with the lowering system. To remove the remaining stay and anchorages from the deck and pylon, new coring machines were designed and built. With diamond-hardened steel teeth, hydraulic pumps and water cooling systems, coring machines are able to cut through the concrete pylons and blisters at up to 200 millimeters per hour. At times, the machines also have to cut through reinforcement bars that were placed too close to the existing anchorage and stays. Though this slowed the speed of the coring, the machines nevertheless successfully completed each hole at an average of 7 days per hole and with a minimum of only 1 working day to finish a hole. Once the carrots are extracted from the holes, new anchorages are installed along with galvanized steel bearing plates, formwork tubes and guide tubes. The area is then ready for the new Freycinet cable stay. It is assembled by first soldering the HDPE pipe sections together to create the desired length. An anti-vandalism tube is then attached to the deck level end of the pipe and the sheath is hoisted up. Monostrands are then threaded through it into the anchorages and tensioned using Freycinet's unique iso-tension system, completing the new stay cable. The process of lowering the working platform, moving the temporary stays, cutting out the existing stays, coring and installing new stays is then repeated for the next level, starting from the longest stay at level 12 to the shortest stay at level 3. When all the new stay cables are installed, internal hydraulic dampers are placed on each cable stay from levels 12 to 5. The dampers reduce the fatigue of the strands by lessening the vibration and absorbing energy through oil viscous shearing. With the completion of the stay cable replacement project, the Penang Bridge, although in operation for the last 25 years, now enters a new phase of engineering excellence. Thanks to Freycinet's stay cable technology, the Penang Bridge, besides looking new and ultra-modern, now enjoys protection against corrosion, inspectability and replaceability. Motorists can now enjoy a smooth and safe drive across this magnificent bridge until the next century.